I'm going to talk about a very complex topic, managing data aggregation in distributed architectures, in edge computing. It sounds complex, but I assure you it's not. So what is the issue? Why are we talking about this right now? Well, I'm European. I manage Code Value Romania, and I'm front-facing with European customers. And coming next month, most of my customers are going to be in a big pickle. Why is that? So there are some things that we Europeans like to do, and that's overcomplicating things. That's something that we are very good at. Why and why now? So let me tell you about it. Europeans, as myself, love regulations. We love to regulate. So you all know the joke that the bottle cap in Europe, when you open the bottle, you need to have the cap connected to it. That's the biggest innovation out of Europe for the past 10 years. But there's something else coming, and it's actually happening right now. It's been in the works for a very long time, but it's going to be due next month. What is it? It's the NIS2 Directive. It's a new bottle cap, but it's for your infrastructure. And it's going to you can either see it as a big pressure on yourself, as on your infrastructure or on your team, or you'll see it as an opportunity. Now, speaking with a lot of people, the main idea is, when is it due and what am I exposing myself to? Because I will try to comply to it on the last very day when it's due. As you can see, it's mandatory by October, and it has a hefty fine attached to it. But what is it actually? Starting October, everything that's considered critical infrastructure, and it doesn't really matter if you're a public or a private company, needs to be more resilient. And why is that? Well, we all know what happened 5 years ago. Everybody stayed home, and there was a huge pressure on all existing infrastructure. So new complex requirements are coming out of post-pandemic necessities. Obviously, with the advent of AI, everything is multiplying as we speak. Higher volumes of data put a strain on infrastructure. Another problem is everything that has to do with cybersecurity. Having a distributed network means that every node of your infrastructure, of your network, is vulnerable. So you need to address that. And obviously, the last point is the legislation that fully impacts your business. Again, it doesn't matter if you're a private or a public company. But this sounds a lot like hardware. Why am I talking about this on a dev tech quality panel? It's not just about the hardware. The hardware is an opportunity. The software side is where it's getting exciting. So when you have edge data collection, or when you have distributed infrastructures, you think differently. You're no longer thinking linear. You're thinking in different time zones, in different locations, in different capabilities. So how was it before? Let's say you have a factory, you're producing goods, you have some production lines, some infrastructure that's helping you aggregate that information, and maybe a dashboard used by your back office team. So how does that look? Well, again, your first layer is your production line, all your devices, all your sensors, everything. The second one is, and this is even optional in some cases because there was a top-down architecture model, is your aggregation, synchronization services. Finally, you've had your head office and field services, which would give you some sort of information of what was happening, but you've probably also experienced information that was beyond a month old or beyond the scope of your requirements. And in the best case scenarios, you would have also access to your information over the internet. If you are going to be changing the way you look at your infrastructure and your processes internally, you can also do that by optimizing the way you collect and analyze data. So here comes the cell concept. What is a cell? It's an individual unit that has know-how, autonomy, intelligence, and control over that specific unit and branch it's working on. So you'll have a firewall, you'll have individual processing units, and you'll have control over them. So if you're thinking of it, it's like a hand that has a mind of its own, independent of the body. And God forbid something happened to that hand, you can swap it with a new one and you'll be on your way. So that sounds cool and all, but what are the challenges? How does it work? What are the advantages? How complicated is it to implement that? Well, first of all, you need obviously to think in different terms. You need to address different issues that you've probably never had before. So, for example, what is local aggregation? When you are no longer thinking of a head unit and multiple data sources, local aggregation means that you need to collect all that data into one specific node, into one specific cell, which we'll talk about a bit later in the speech. Aggregation in itself is a very broad term, and it's going to propose different challenges. What about hierarchical processing? That's a very difficult word for me to say. So you could have multiple layers, and all of them are individual layers that can act independently, but they also need a, let's say, master, a main orchestrator. So those are other challenges that you might have. Filtering, compression, synchronization, all things that come from working in distributed systems and fashions. So aggregation, as I said, is going to be one of the biggest issues you'll face. First, it's functionality. How is that going to work if I have independent arms working together, working independently, but they also need to communicate together? What about different locations that need to communicate together or work independently? And also temporal issues that I might have while working over multiple continents or over multiple locations. So these are aggregation techniques that help you streamline different data points and different connections from independent cells working on their own. I need to maintain accuracy. I need to take care that I don't collect too much information. Telecom providers are always going to have this problem. There's a fine line between connecting data, collecting data that shows you user behavior or consumption, and collecting too much that you are providing reports with a month delay. And obviously, it's also latency sensitivity because everything scales very fast, exponentially. So let me give you an example, because I think I've been too abstract until now. So we have a factory, a simple factory. It has some cells, some sensors that collect temperature information and vibration information, let's say. So I need a way to independently and autonomously communicate with those machines within my factory and to help them be as efficient as possible. So I start for the first layer, which is my PLC, my controller. It's a simple arm, robotic arm, doing a specific task. But remember, that arm has intelligence in it. So how do I achieve that intelligence? Part of the directive and the new regulations is I need to have some sort of intelligent device connected to that arm to isolate it, to provide autonomy. So now I have my edge nodes. Independent CPUs, independent processing units that I can use to control my arm and tell it what it needs to do. Additionally, you'll see between the last and the and the first to last, there's also cross communication. So I can communicate between themselves also, independently. I can say to my left arm, can say to my right arm, clap. So that's all fine. It's going to handle independent actions. As long as it's not going to try to strangle myself, it should be fine. But that's where the second layer comes, which is the aggregation service. That's the orchestrator. That's the service that is either remote or in a central location that's going to issue commands and expect autonomy from my nodes. And the last part is what we as humans are going to interact with, which is the application service. So this way of actually communicating with my edge devices or my, let's say, automatic processing units is going to greatly increase autonomy. So in the first layer, I'll have temporal and functional autonomy. And in the second one, I'll have spatial autonomy and consistency. This means I'll have less latency, more automation, and then enhanced security because everybody is thinking on its own. Everything is independent. One final use case. What is quality in this scenario? So again, as I said before, the traditional use case is I used to have some devices connected to a PC with a centralized server. Everything was attached to it. If something went wrong, I wasn't able to catch it until the very last moment, until the very last point where I could have stopped my process and I could have saved myself a very tedious production process. So going back to our traditional setup, obviously first of all, I'm not NIS2 compliant, so I'll have a big problem starting next month. But then there's also a lot of edge optimization possible and a lot of network traffic and redundancy that is not built into the system. So if I'm thinking of an edge setup, again, we'll have the same scenario with our edge nodes. They communicate between themselves with an open protocol, something that's very standard in the industry. They also have firewalls. Now, firewalls consider them either firewalls for hacking purposes, protection, or consider them quality gates, something that will help you prevent continuing with a defective unit. And then again, the same aggregation service and the application services last. So I'll have real-time edge optimization, low network traffic, because not everything is sent into a central location. Everything could be handled by my independent arm thinking on its own. And I have low security risk because everything is, again, independent. So in conclusion, what started out as a very complex regulation out of the EU, this might be an opportunity to scale in style while complying with the regulations. Obviously, this also takes a lot of effort, but I think your developers will be very happy for that. Thank you so much.